Hello, this is Bradley Needham. I'm going to be talking about const and mutable. I'm going to take a simple class and make it bitwise const correct, then change its implementation and make it logically const correct but not bitwise const correct. So I'm going to start with this simple class student, and student has a name and a list of scores. And some of the things I'd want to do with a student is I'd want to be able to get the name, and I'd also probably like to get the GPA of the student. Now, what is the GPA? The GPA is basically the scores added together divided by the number of scores that you have. So let's do that. Okay, and of course, if I'm going to have scores, I want to be able to add the scores to the student. Okay, so I have my student, and I might also have an external function that utilizes the student, and that's a print function. And this function is going to print out the student in some sort of formatted way. Now you'll notice that the print function here takes my student by const reference. And the reason for this is, of course, it's taking it by reference because he doesn't want to have to copy the student, especially if the student happens to be large and have lots of data associated with it. And he's taking it by const reference because he's making a promise here that he's not going to make any changes to the student object that you pass to it, even though he's taking it by reference. He's saying, yeah, you can pass it to me by reference for efficiency, but I make a promise that I'm not going to actually make a change to the student, even though I'm getting it by reference here. So let's go ahead and implement the print method. Okay, so here's a fairly straightforward implementation. We're just going to print out the student's name and its GPA. Well, notice that I've got these little stop signs here, and this is the compiler telling me that this function is not viable here. And the reason why is that I've taken this student by const reference, and my student class is not const correct, because even though the function, the member function name and the member function GPA do not change the internal state of the student object, I have not told the compiler that they will not change the internal state. And so when I pass this by const reference, the compiler is saying, hey, you cannot call the name or the GPA method on student because they are not const. So in order to repair this, I have to tell the compiler up here in my student class, I'm going to have to tell the compiler, hey, I promise not to change the internal state of this object when you call the name function. And I do that by specifying const after the function. So I specify const here and I specify const here. And if I go back down now to my print function and I look at my print function, sure enough, those little error codes are gone, and so it's not complaining anymore about calling name or GPA because the student class is now const correct. Notice I did not add const to the add score method or member function, and the reason why is that add score is changing the internal state of the object. And so in order to make the class const correct, the methods that are not changing the internal state of the object need to be const, but the ones that do change the internal state of the object should not be marked as const. So let's try this out and see how this works. I'll go ahead and create myself a student and add some scores and then print out the student. Maybe add another score and then print the student out again. So let's run that. And sure enough, we get the student printed out and the GPA, and after I changed the student's GPA by adding another score, again the GPA comes out as a new value. Okay, so now we have our const correct class, and this is a bitwise const correct class because it's not changing any of the internal state with these methods, name or GPA. But let's say that as we use this student class in our system, we find out that users of the class seem to invoke this GPA method over and over and over again, and a lot of times they're invoking it even when they have not added any more scores to the student. They're just wanting to query what was the GPA of the student, what was the GPA of the student. And every time we're redoing this calculation, well, that could be a performance penalty for us, right? Because basically we don't need to recalculate this over and over again if there haven't been any new scores added, because the value is just going to be the same. So we decide to enhance our student class. Maybe we can cache the value of the GPA. So in order to do that, let's add a couple new data members. All right, so we've added a flag that will tell us whether the cache is stale or not, and we've added something to store the cache in, the actual GPA value being cached. So let's initialize those values, and now let's see how we would actually cache the value. So down in the GPA method, I'm going to check first to see if the cache is stale. If it is stale, I'm going to go ahead and calculate the GPA and store it in the cache. After I store the value in the cache, I need to make sure and say that the cache is no longer stale, and whether the cache is stale or not, I want to make sure and return the cached value. So if the cache happens to be stale, I will calculate the value, store it in the cache, and then mark the cache as not stale, and then return the cached value. Otherwise, if the cache is not stale, I will simply return the cached value. Now down in the add score method, I basically have to say that, hey, once I've added a new score, the cache is now stale. So this looks all good for caching our GPA value, but you'll notice over here I've got a couple compiler errors. The compiler is complaining to me about something. And what the compiler is complaining to me about is this little promise that I made to the compiler. When I made the GPA method const, I made a promise to the compiler that I would not change the value, the internal state of this object. And by setting this cache value and setting this cache flag, I am changing the internal state of this object on a bitwise level. Logically, however, I am not changing the value of the student. These cache values don't really have anything to do with the student, they're just an efficiency gain for us. So when I query the GPA, whether I recalculate it every time or whether I return you a cache, you're still going to get the correct GPA value from the student. So as a user, it's still const to you, and you still want to be able to use it in your functions like the print function. So the way we tell the compiler that, yes, we know we are actually manipulating the bits of the class, but we aren't changing the logical constants of that, is through the mutable keyword. So I go back up here to my data members, the ones that I want to be able to change even in a const member function, I make them mutable. By doing this, you notice I no longer get those errors from the compiler. And now if I go back down here to my main, I can maybe change these cache values here so we can see a little bit of a change. I get my printout student, and then it still does change the value when I add a new score. Okay, I hope this helps.